So yesterday we are seeing some basics about firefighting and like what is the sprinkler and like how does the sprinkler operates. We were seeing this thing. Actually, if you talk about the sprinkler system, so sprinkler is a very actually big topic because yesterday in video also we have seen that if the building is completely sprinklered, so almost that building can be saved. Normally what happens if you have attended any like fire drills, because most of the like nowadays the fire drills are very common, so they will show one for sprinkler also, but that sprinkler drill will not be taken in a general area because once the sprinkler is used, it has to be replaced. So there you will understand that from one sprinkler, like how much water is flowing. So normally, like if you check Nfpa, as per Nfpa, this data is given that one sprinkler can go up to 22 to 28 GPM actually. So on from one sprinkler, this much of water can flow 22 to 28 GPM. Now, this is a very it's a very what you can say, it is very more water actually. So that is why the sprinklers are very important. And recently, and the most important thing in sprinklers are how you are positioning it. Okay, like I will give you one example about what is the meaning of positioning of sprinkler. Suppose just imagine this is my building or any space. Suppose this is one space, and just imagine this is 10 meter by 10 meter. For example, it is a 100 square meter space or 1000 square feet area. Suppose if I am placing sprinklers like this, one sprinkler here, one sprinkler here, one here, and one sprinkler I am keeping here, one sprinkler here, and one sprinkler here. Now, just imagine here that I have done some very big mistake. I have emptied this area. Okay, I have created one very big, what you can say, a vacant area here. Just imagine if fire occurs in this region. So what happens when fire occurs? This sprinkler cannot alarm for this area. Okay, this sprinkler can alarm, but what happens once the fire starts? It will go to a very peak level. Okay, like within a fraction of seconds, or if the area is very critical, within a very milliseconds, it will catch fire. So just if I am keeping 6 sprinklers in this manner, what happens means my design will definitely fail, because here I have not fully protected the building. The main thing is that we have to go for the 100% protection. Okay, sometimes what happens in some cases, for example, you cannot place sprinkler here at this position. Why? Means because sometimes some wall beam, anything will come here. Okay, or sometimes some HVAC diffuser will come. So what you have to do, instead of placing here, you can little bit shift either to here or to here, but you should not create a void space when we are talking about the sprinkler. Now recently we had one accident in Mumbai. Okay, I think everyone knows about this. It is a almost 60 floor building, and the government agencies, what they are telling, that the reason for that fire is the what you can say, location of the sprinkler. I was just going through one document. In that what they have told, that the tenant was living in that particular flat. They have mislocated the sprinkler. Okay, normally in high-rise building, what happens, I will tell you. I think this practice is followed everywhere. Suppose this is a building, any high-rise building. So the contractor or whatever the developer, what they will do, they will just give one tapping here. Suppose this is one flat, so they will give one tapping and they will keep it for future purpose. Whenever a tenant is coming, what they will do, they will just place sprinklers according to them, but everything should be done according to Nfpa only. So here what they are telling, that whoever the tenant was there, so they have just misplaced the sprinkler. Because of that particular reason, a short circuit happened, and because of that, the 19th floor, the fire was, it is very famous here. What happened? like I think 1 week back. So this was the like ongoing investigation is going on in that. But what I want to tell you is that just because you misplaced or mislocated one sprinkler, so what it will affect? It will affect the entire. Uh, Sometimes if the building is categorized at extra hazard or any what you can say compressed liquid or anything will be there. So in that case, what happens? The damage will be more. So that's why I will tell you that placement of sprinkler is the most important thing, because if you place more number of sprinklers, okay, just we will mute it. Suppose if in your building, if you're placing some extra sprinklers, nothing will happen. But our mentality, what it will be there, suppose in place of 5,000 sprinkler, we will try to reduce the number of sprinklers. We will try to go for 4,800 or something, just to reduce the cost. But if you are placing some extra sprinklers, nothing will happen. Okay, because it will give you the 100% safety only. So in our next section, we are going to study about the Nfpa 13 norms. Okay, so first we will see what is this Nfpa 13. Like as I told yesterday also, once again I will tell you this Nfpa 13. If we try to break down, we can break down or categorize in three patterns. First, it will talk about some sprinkler installations, or the types of sprinkler. You can say that type of sprinkler it will talk. And one section it will talk about how to do the hydraulic calculation. Hydraulic calculation is nothing but how to supply water to the sprinkler. And one section is entirely given about the storage type of building. Okay, there are a lot of storage buildings given in Nfpa 13. So I have just categorized into these three sections. So as I told you yesterday also, this storage part is a very big topic and it requires almost 2 hours to understand it. So we will keep this topic separately, because if we go in depth of this particular topic, we will get confused. Our main focus is the hydraulic calculation. So in Nfpa 13, a hydraulic calculation procedure is also given, how to do the hydraulic calculation, and they have given certain sprinklers also. And apart from this, some definitions and all, obviously it will be there. Some definitions, some regulations, every standard book will have. So we will try to crack down those things, and we will try to understand why these sprinkler systems are important. And nowadays, like we are feeling the importance of firefighting, because recently I think since 1 year I have heard so many accidents because of this firefighting throughout the world. And I think in this the very what you can say, the devastating was that one, the Lebanon one. I think everyone has heard about that. So even that was also at some places it was also the what you can say, communication from the firefighting system. So that's why firefighting systems are very important nowadays. So we will go to this Nfpa 13 now. So here you will see this is just, I have taken Nfpa 13 2013 edition. I think I have the I have the latest edition also, 2021 or 20, but I need to search. But nothing is difference between those standards. Only some pages are added here. So this is the book, okay, Nfpa 13, and it will talk about the installation of sprinkler system. Now, installation of sprinkler system is everything, designing and how you are placing the sprinklers. So let us try to quickly understand this standard. I have highlighted some points, so I will directly go to that. See here, I have at some places I have highlighted like this, just to understand that, okay, these are the points where we have to little bit focus. Like here, I have just highlighted for conversion factors. Suppose if you want to go for any conversions, so you can check this also. They have given some conversion factors, and some hydraulic symbols are also given. Okay, it is normally we don't require these symbols, because whenever you are doing any project, whatever the company you are working on, they will have some standard legends. We can follow that also, but still, if you want, you can follow. And here you will see that the list of Nfpa publications are given. There are so many Nfpa standards, Nfpa 11, 14, 15, 20, so many standards which are listed here. So we cannot complete all the NFPA standards, but we will try to complete maximum standards. And I will try to share you the maximum NFPA standard copies. Okay. So that you can go through that. And there are so many standards here given, so which is not required for us. You can check this. Some definitions are given in every standard. Some definitions will be given. We can leave these definitions. Whenever you have time, you can study those definitions. And if you go a little bit down, I'm trying to show you some highlighted points, some important points. Okay. And here they have given the classifications. Okay. Classification of occupancies and commodities. Like as I told you, the classification in NBC is different and classification in NFPA is entirely different. Classification of occupancies and commodities. So here they have given light hazard, ordinary hazard, and extra hazard. These are the three classification. Here they have just given the definitions. Light hazard, ordinary hazard, group 1, group 2, extra hazard, group 1, group 2. And what is the meaning of commodities? Again, commodities will come in this storage chapter. Okay. So commodities is nothing but like there are so many things are given in commodities also, like plastic, glass, wood, so many things are given. So this is the classification of commodities, and these are the major classification: light hazard, ordinary, and extra hazard. And I will also say that most of the building are under light hazard only. If you see hospital, hotels, restaurants, commercial offices, or any banks, there are not banks. I think there are so many buildings. Day to day, what we are designing, everything comes under light hazard only. Ordinary hazard is little bit different, and extra hazard is a little bit different. Yesterday, I have shared you this notes. From this, you can check. Just a minute. Here we have written only the classification. Not just given here. See here. If you check this, you will see that most of the buildings are coming in light hazard only. Clubs, education, hospitals, churches, libraries, museums, offices, so many things. And the same classification is given in NFP 13 also. You just need to search it. Okay, anywhere you will find this. From here only I have copied. So this is also one of the important thing. Then here you see, I will not focus on this commodity part because as I told you, it is consists of storage chapter. So we will leave this for now and we will see later. Even when you see the classification of plastics, rubber companies are also given here. So many things are given: group A, group B, group C. So we don't need this thing. Next, just please mute it. See, this is the K factor. Okay. Like yesterday, I told you that I have shown you the K factor also. So that K factor is given from, I have taken from this particular NFPA 13. The K factor range starts from 1.3 and it can go up to 29.5. Okay. It is GPM per PSI. So many things are given. You can just go through that. What we are following is this factor, 5.3 to 5.8. The K factor which we are following generally is 5.65. But whenever you are going for storage type of building, in storage type of buildings, K factors are different. Okay. But for all light hazard and ordinary hazard, we need to follow K 5.65 only. So that also, if anyone is asking you how you got the K factor, you can tell about this table also, because this is the table. This is the most important table. The same thing you will find in Allied software also. Yesterday, I have shown you the K factor table is uploaded in Allied software also. And that also taken from the NFPA 13 only. This is also another important thing. And next you go, there are some definitions given. And this is the temperature rating. See, yesterday I was showing you this temperature rating only. So this is the glass bulb colors. This is the link, the fusible link colors. This is the temperature classification. This is the temperature rating in degree Celsius. Start from 57 degrees Celsius up to 343 degrees Celsius. This is the ceiling temperature. We don't need to bother about the ceiling temperature. We will be focusing on the sprinkler or the room temperature. you can say the room temperature also. This is the temperature ratings for the glass bulb. So it starts from 57 degrees Celsius and go up to 343, and maybe higher also it will go in a special cases on any special occasions, like if you are designing for any marine industries like or ports, maybe if the temperature is very high, so maybe that special type of sprinklers are also placed. How we have to understand the temperature sprinklers? By the color code. These are the color codes given: orange or red for the ordinary temperature, yellow or green for the intermediate, blue for the high, extra high purple, rest everything will be black. Okay, for very high it will be black. This is the glass bulb color. This is the fusible link. So if you see in the fusible link, orange is considered for your ultra high, but in the glass bulb, orange is considered for the ordinary type. So like that, you should always check. This is also one of the important thing given. Next, these things you can leave this. And here I have just highlighted one point here about the CPVC pipes. Now, nowadays, I think if you know, nowadays what is happening means in India, we are not going completely MS or GI pipe. We are going with the CPVC pipes also. Maybe outside India also they will follow the same pattern. So why means, because if you compare the price of MS pipe and CPVC pipe, obviously the CPVC pipe cost is very less as compared to MS pipe. So I have just highlighted this point so that whenever you want to study about the CPVC pipes, you can see here. They have given something about the CPVC pipe which is connected with the MS pipe. I will show you just a minute. So nowadays, this is very common in India. So most of the contractors, what they're adopting, they're simply avoiding this MS pipe for smaller sizes like 25 mm, 32 mm, 40 mm. Simply they are going with the CPVC pipes. I think up to 65 or 50 mm, they can use CPVC pipe. So here I have just highlighted one point. Okay. And after that, just let it open. Something they have given about the welding requirement, joining of pipes. So these things you can go through later. Okay, this is not required for us right for now. Fire department connections. So here I have highlighted this fire department connection. Why means, because here they have given the Nfpa standard for fire hose connections. So you can check this Nfpa 1963 whenever you want to go in-depth study about this fire department connection. Now, what is the fire department connections? Fire department connections are usually like fire brigade inlet connections only. Like sometimes it is called as fire department connection or fire brigade inlet connection. Suppose any firefighting team is coming, so they will try to search this, what you can say, this accessory only in the building, so that they can supply water to the building. So just let it open. I will show.
Mr. Atif.
Yeah.
Mr. Atif, I think you're talking about the breaching inlet.
Yes. That is breaching inlet only. It is. This is a technical term actually. Fire department connection. We will FBIC breaching inlet, 4-way breaching inlet, 2-way breaching inlet. But this is the standard term which is given by the NFPA.
What's the difference between 4-way and 2-way breaching inlet?
This is 2-way. This is 2-way. And here only we'll check 4-way. This some 6 ways, I think. This is 3-way.
What's the difference?
Difference, I will show you. Just a minute. Let it open. Difference is that 4-way means it can go in a 4 different places. 2-way means it can go to the 2 different places. The pipes can be connected from 2, what you can say, from 2 places you can connect it. Mostly we will go with the 4-way. Why means, because 4 ways can be connected to the 4 different places. Like one, it can go to the underground tank. One, it can directly go to the building. One, it can go to the main main sprinkler line, and one you can connect with the external hydrant also. Just let it open. I will show you. Okay. So this is something about the fire department connection, and this is the most important parameter actually, fire department connection. So we have to follow the local authority. Whenever you are designing any, or whenever you are selecting or buying any fire department connection, you should be aware of the local guidelines also, because we should be in, because sometimes if fire occurs, so this is the major, this FBIC or FDC will play a major role. So here's something written about those. Okay. So here you see four fire department connection.
This
Something it will like this, four way. Suppose this is the four way. So at one place you can take pipe to the sump. For example, one pipe you can connect to the sump, one pipe you can connect to your sprinkler system. For example, the main header, one pipe you can connect to the bore. I'm just giving you example. And one pipe, suppose you want to connect to the yard hydrant. So like that also you can. So whenever the fire department team is coming, so what they will do, they will just insert a pipe here, and then the water will, yeah. This is how.
What is the first and the third one?
Sorry?
The first and the third. What is the text? The first and the third high landing valve. Sorry, inlet. What is the name? Boring.
Fire
what did you write
inlet.
For?
Fire brigade inlet connection. FBIC. Fire brigade inlet connection.
No. This one, the first one. Oh, okay.
This is bore. I'm just giving you example. You can connect anywhere.
Bore.
Bore is nothing but like the underground bore. From the underground, we will get the water. Fire brigade inlet connection. I will show you. Inlet four-way connection. See, this is the four-way connection. Or sometime you can use in this pattern also. This one, this one. So there are different what you can say, the shapes and size are available. So in India, usually we use this one, four ways. So you can connect four pipes from the four different places. So like that, it will be given actually. So here, if you want to study about the FDCs, you have to go to the Nfpa 1963. So, so many things are given about that. And let us move a little bit. Okay, here some things are given. You can just leave because anyhow we will come to that portion also. Here something is given about the air.
Those the breaching inlet, we can use it for both wet and the dry riser, right?
See, this is only used to get water from the fire department team. This whenever you have any fire, so the fire department will come and it will try to search this FBIC. So wherever this FBIC will be there, they will just put their pipe and they will supply water to the building. Now it is our duty that we should connect this system properly to our buildings. If we couldn't connect this building to the building, then whatever the efforts which fire department team is making, everything will go in vain. So that's why we have to very much what you can say, we have to very much cautious whenever we are using this system. And I will show you in schematics also, drawings. You will understand how this FBIC or breaching inlet is connected to the building. Okay. So normally whenever the firefighting team is coming, you have to understand that the fire is what you can say, the fire is very critical. Otherwise, firefighting team will not come for small fires. So you have to be ensured that your system is accurate whenever any huge fire or major fire occurs. So our system should be accurate. But sometimes what happens, because of the nature of fire, our systems get failed. So the fire department team will come and they will try to assist us in the, normally they will try to protect the building. So that's why you will see that whenever the firefighting team will come, they will have two pipes. One pipe, what they will do, they will directly sprinkler in the building. And one pipe, what they will do, they will directly go and try to find this breaching inlet valve. Because if they connect this pipe to the breaching inlet valve, so this breaching inlet valve will go indirectly to the building only. But this pipe, what they will do, they don't want to wait for these tanks to be filled. So that's why what they will do, just they will take out one pipe and they will try to extinguish the fire in the building. But Simultaneously, they will also take one pipe and they will try to fill whatever the sump we have designed here. So they will try to fill to the sump here. Okay. So this is the function. We will see that later. I have written also something about the system air pressure, which is something here highlighted. This is for the dry systems actually. And here you will see there are different systems are given, pressure gauges and so many things which is not required right now. So we will just go a little bit. So many systems are given here. Some drawings, arrangement of supply piping and walls. You can leave this because anyhow we will see this later in this images also. Here they have given some water temperature. What should be the maximum water temperature? They have given the water temperature. The maximum water temperature flowing through the sprinkler portion should not exceed 49 degrees Celsius. So this is one, sometimes if you are feeling that the room is getting hotter or sometimes you get the false signals, false alarm signal. So that time you can check the temperature of water also. Because of the like water temperature also sometimes what happens, we get the false detections also. So these things normally it can be helpful when you are checking the system. You can check the water temperatures also. If the temperature is going little bit higher, then there may be chances that the fire can occur, because for fire to occur they require rise in temperature. So rise in temperature can be occurred from any like anything. It can either be temperature of equipments, or it can be either temperature of any like ceiling, or if you have any cables, if there what you can say short circuit happening, because of that also temperature. And this is also one of the reason, water. Sometimes the water is like getting hotter and hotter, and it may become the reason for fire to occur. So many things, just I have highlighted some point and you can just go through these points, because in one day you cannot become perfect in NFP 13. You have to study, and we don't have that much of time to go from each and every point. That's why I have highlighted some important points here only. Okay. And next you go, so many things are given. These things are not required. So because it is talking about the each and every like system, each and every building. So that's why they have given so many additional things here. Now this chapter 8, from chapter number 8, it will talk about the installation requirements. Installation is nothing but positioning of sprinklers. How you are positioning the sprinklers. This is what installation means. So from this particular chapter, we will see about the different types of sprinklers and how they are positioned. First point they have given here, the very first point, the maximum area limitation. So if you remember, here also I have written this point. So yesterday we were seeing this point. I think where it is written, somewhere I have written that particular point. The maximum protection.
20 it was 20 meters square, I believe.
Sorry?
It was 20 meters square, I think.
Yeah, here I have written the area limitation. So this I have taken from here only. Now, what is the meaning of this particular? You need to understand the maximum floor area or on any one floor to be protected by sprinkler supplied by any one sprinkler system shall be as follows. Now, for example, if you have a floor, here they are talking about the floor area. Floor area is entirely different than your what you can say any building area or anything. So here they have given the limitations. This is the maximum limitations. 52,000 square feet for light hazard. This is the floor area. It means that one source, okay, suppose this is my underground tank, for example, this is my pump and it is supplying water to the floor, for example, whatever the sprinklers. So the meaning of this particular point is that my one source can supply up to 52,000 square feet. If the building is light hazard, my one source, okay, this is my one source. This is my single source. This is the underground tank, or it is sometimes called as fire tank also. You can give any name, fire tank, underground tank, or fire sump, anything you can call it as. This is my one source of, okay, one source. So it can supply maximum up to 52,000 square feet area as per this point. For ordinary hazard also 52,000, for extra hazard 40,000, and for storage type of building 40,000 square feet area. It is talking about the floor area. Okay, don't confuse this. Here it is talking about the floor area, and I think 52,000 square feet means it should be something like, suppose if I take 100 feet this side, this is my 100 feet, means this should be my 500 feet. So I don't think that this much of big area, like any floor area for commercial or any residential building, it will be there. Okay, maybe for a very big warehouses, it might be there. So what we can do if we are exceeding more than 52,000 square feet area, suppose we are having additional 20 or 30,000 area. So simply what we can do, we can go with the two sources. One source we can go.
We need another point.
Yeah.
Another point.
Yeah, we can go for another source because one source can cover up to 52,000 square feet area only as per Nfpa. We are not talking ourselves, because in Nfpa only it is given clearly the maximum floor area. So like that we can go. Okay. And here they have given some points here where single system protect extra hazard high, right? The extra hazard shall not exceed the floor area, whatever the points are given, but this is the most important point, whatever it is given here. And then something is given about the temperature ratings also. Yeah.
Sir, I have one question regarding related to the limitations of area.
Yeah.
Nfpa says that the 50,000 square feet area for the light hazard to cater the one riser single sprinkler riser,
Yeah.
right?
Yeah.
So there is any limitations related to the interior furniture or the parking levels or the office floors? Is there any criteria? Because in the office floor there is a lots of cabins, lots of rooms, and lots of number of sprinklers will increase.
I don't think it is there, but if it might be there, then that will be given for the civil department, not for us. Any civil department or architecture department, they might be having some limitations, because you will see that all the basements are like created in a same pattern only. So there might be any limitations for civil people or for architecture people. But as for firefighting or any MEP, we don't need to bother about the areas. Whatever the area architect has designed, so we have to consider that only. Because
what I'm talking about. Hello.
Yeah, hello. Tell me.
So, yeah. So I just wanted to know, because of the water volume requirement. So if we increase the number of sprinkler, then obviously the water requirement is more.
No. Water requirement will never increase. See, water requirement will never increase. Even if you are designing for 10 floor building, or if you are designing for 30 floor building, or you are designing for 60 floor building, the water requirement will never increase, because Nfpa has given clearly how much water we have to use. That's why we will come to that point also, because you will find that they have given about the water requirement also. Just in after some pages you will find that.
Okay. Nice.
Here they have given the
Mr.
Yeah.
Mr. Atif, for the extra area, which is more than 5,000 meters square, we need another zone control valve and another pipe tap from the main pipe, right?
Yes.
Discharge,
No,
right?
I think you can take entire different source.
Yes.
You can go with the entire different source.
From another,
you cannot tap from the
another pump?
You need to go with another pump, because you cannot, because as per this point, we cannot tell that the same system can be used for by using one more tap. We cannot go like that, because here they have given the maximum area.
Okay.
So you can go, because you might be doing that, but the system may fail. Then who will be responsible? Because they will come and they will check the Nfpa regulations, and they will say that in Nfpa they have not given that So that will be the major thing actually. Because whatever we design, there will be a NOC. Design NOC will be there. They will reject it in the very first case only. Now here they have given some temperature. Okay. Here they have given the minimum nominal K factor of 5.6. Sprinklers with K factor less than. Okay. So here I have just written highlighted one just to understand that the minimum K factor which we are using is the 5.65. Below that we don't have to use. More than 5.6 we can go according to the type of building or according to a type of commodity, whatever it is. So this point is highlighted once. And next we will go directly for our types of sprinklers. If you go here, now so many things are given here which is not required here. Here they have given one 8.5 section, position, location, spacing and use of sprinkler. And here one point is given: the maximum area of coverage of any sprinkler shall not exceed 400 square feet. This is the most important point. This point, what they have given, the maximum area they have given. The maximum area of any sprinkler is 400 square feet. So what does it mean? It means that suppose if you have one sprinkler, suppose this is a deflector. So how it will go? The water will come like this, for example. So if the water is coming like this, so what will happen means we will make the circumference. For example, we are making one circumference of this particular sprinkler. So what it is telling, this circumference should not go more than 400 square feet. One sprinkler circumference is 400 square feet. Simple, in simple definitions. I hope you understood this. The sprinkler, one sprinkler is covering 400 square feet area. The coverage of one sprinkler is 400 maximum. Here it is telling the maximum. It is not talking about the minimum, but it is talking about the maximum. We cannot predict that one sprinkler can go 500 or 600 square feet. We cannot predict because Nfpa is clearly telling here that the maximum area of coverage for any sprinkler, and they have mentioned here any sprinkler, whether it is a CMSA sprinkler, ESFR sprinkler, pendant, sidewall, upright, it cannot exceed 400 square feet. Now all the manufacturer will design according to this point only, okay, because they will be considering this only. Next you see, here you will find the sprinkler spacing. The maximum distance between sprinklers and the minimum distance between sprinkler, everything. If you remember this point, here I try to write the same thing. So yesterday I told you also that certain remarks I have written here. So these remarks I have taken from the Nfpa 13 only. First, maximum protection area, maximum spacing between two sprinkler, maximum distance from wall, minimum distance from wall, minimum distance between two sprinkler. Just understand this. I think. Yes. Suppose this is one.
At the top, it is mentioned 225.
Sorry. Now,
it was mentioned 225 feet square meter.
Yeah, we will come to that. We will come to that.
Previous section.
Yeah. Suppose this is one sprinkler and this is one sprinkler. Two sprinklers are placed. So simply Nfpa is telling what is the distance between this, what is the distance between this, what is the distance between this, and what is the coverage area for this sprinkler. So all those 5 points will cover this one. Maximum distance from the wall, minimum distance from the wall, maximum distance between two sprinkler, minimum distance between two sprinkler, what is the protection area. So that thing only I try to write here. Okay. Now we will come to this point. Once you go 8.6, section number 8.6 will start talking about the standard pendant and upright spray sprinkler. This is the first sprinkler. Now we have come to the first sprinkler, standard pendant and upright spray sprinkler. And here what they have written, just try to understand the one pattern, one sprinkler pattern. If you understand, the same thing follows for all the sprinklers. Okay. Now here what they have done means they have given one table here. This is the important table. The protection area and the maximum spacing of standard pendant and upright spray sprinkler for light hazard. So what is the meaning of this table means, in this table, they will give us the 2 points. First point, what they will give, what is the protection area? Protection area is nothing but coverage. And second point, what they will give, the maximum spacing between two sprinklers. So these are the 2 points which is given here, protection area and the maximum spacing. And it is talking about the standard pendant and upright spray sprinkler for light hazard. Okay, here you have to be very much specific, because one table they have given for light hazard, one table they have given for ordinary hazard, one table they have given for extra hazard, one table they have given for storage type of building. So you should not get confused. And in this table, you will see that there are so many construction types are given, so many system types are given. Which one we have to choose? That is the most important question. Now, since it is a light hazard only, but which one we have to choose? So I will tell you that. Now, non-combustible construction type means, what is the meaning of non-combustible? Normally, non-combustible is the one which cannot catch fire. Okay, combustible is the one which can catch fire easily, or which can catch fire. For example, paper can catch fire, even glass can catch fire, or wood can catch fire. Okay, so what we have to do, always we have to go with the non-combustible. Like normally, if you see our ceilings, okay, whatever the ceilings we are making, so it will not catch fire easily, even though if there is a fire. So normally what happens, it will become black in color, but normally it will not catch fire. And just imagine if I'm using any material which can catch fire easily, then what is the use of installing firefighting system? So I have to go with the non-combustible only. So construction type will be always my non-combustible. Second thing, what they have given, unobstructed or obstructed. Now, what is the meaning of unobstructed or obstructed means? For example, this is one building, this is one room, and this is also one room. Suppose one beam is coming here. So this is the obstruction in the room, because this I cannot move the beam. I can move the fan, I can move the diffusers, I can move cables, but I cannot move beam because of some what you can say improper design of structure engineer or the civil engineer. The beam has come into inside of the room. So the meaning of this beam is nothing but our obstruction. This is the obstruction. And since here nothing has come, okay, the space is very clear, so it is unobstructed. Now you tell me which one we should select, unobstructed or obstructed? Any idea? Which one we should go for?
Yes,
Obstruction.
Obstructed.
Always we should go for obstruction, because you don't know how the design will go for. If you select unobstructed, then what happens? You have to face lot of problems during the execution stage. But initially, if we are selecting this obstruction, and we have made up our mind that in this room any obstruction can come, so I will go with the obstruction. So always go with the non-combustible obstruction. This is the one. And again, it will talk about two things: hydraulically calculated, pipe schedule. Always go with the hydraulically calculated, because the procedure what we are going to follow here is the hydraulically calculated method. The difference between hydraulically calculated and pipe schedule, it will come, okay, in the later pages. You will understand what is the difference between hydraulic and pipe schedule. So as per this point, non-combustible, obstructed, hydraulic calculation, this is the values. Simple. The maximum protection area is 225 square feet or 20.9 square meter, and the maximum spacing is 15 feet or 4.6 meter. This is for the standard pendant and upright spray sprinkler for light hazard. This is the most important point. Now I will always follow this point only. I don't want to go with this particular points, because combustible or unobstructed less than 3 feet on center, these things I don't require. I will always go with this non-combustible obstructed. If you want to go with the obstructed and non-obstructed also, you can go this point. I think both the values are same only, 225, 225, 15, 4.6. So the values are almost same, but you should be able to explain this to client whenever client is asking you. This is the light hazard. In the same way, ordinary hazard also, here they have not given any, but they have given whenever you are designing for ordinary hazard, you don't need to bother about the construction type, sprinkler system type. Just follow this protection area, this maximum spacing. In the same way, for extra hazard also they have given. See here, pipe schedule they have given 90 square feet, 12 feet. Hydraulically calculated they have given 100 square feet and 12. And here they have given density. So that you need to understand what is the density, what this density it is talking about, because extra hazards are done for the special like industrial buildings only. So you need to check what is the density of that particular material which is installed there, whatever it is. So this is the two. Sorry.
Hello. Sir, one more question. The Nfpa says the maximum spacing in between two sprinklers.
Yeah.
So if there
This is the
any
maximum space.
Yes. So what about the minimum spacing?
That we are coming to that point also. See, there are always 5 points given in NFPA. So 2 points we have taken out. The coverage or the maximum protection area. You can call it as anything, coverage or maximum protection area. And second thing, spacing. Maximum spacing between two sprinklers. So these are the 2 points we have seen. Now rest 3 points. Another 3 points are the minimum spacing. The first point is minimum spacing between two sprinklers and the maximum spacing between sprinkler and wall. This also we have to check. Sprinkler and wall. In the same way, minimum spacing also we have to check. Minimum spacing between sprinkler and wall. So if I take one sprinkler only, like light hazard, suppose if I am taking one sprinkler, standard, pendant or upright sprinkler. This is the pendant and upright sprinkler. So as per this sprinkler value, what I got coverage as 225 square feet I got coverage. What I have selected 225 square feet, or if you want to speak in terms of square meter, it is something 20.9 square meter. Now what does it means? Suppose if you have a space of 12,000 square feet area, how to select for 12,000 square feet area, how to select number of sprinkler? Just divide by 225.
Divide by 100.
Plus method. But this is not right actually. Sometimes this will fail. So how many sprinklers you are getting? 53. So this is one method of calculating the number of sprinkler. On maximum spacing between two sprinklers, it is shown 15 feet or 4.6 meter. Now let us go for minimum spacing and maximum spacing between sprinkler and wall. Minimum spacing. Here only it is given. See, if you go a little bit up here, you will find, first point you will find maximum protection area. So this maximum protection area is given already in the table. Here you see maximum distance between sprinkler. Again, this is also given in table. Next, it will talk about the maximum distance from wall. Okay. See, third point is given here, maximum distance from wall. The distance from sprinkler to wall shall not exceed 1/2 of the allowable distance between sprinkler. Just try to understand that terminology here. The distance from sprinkler to wall shall not exceed 1/2 of the allowable distance. Now, what is the allowable distance? Allowable distance is 15 feet because this is the maximum distance. So what will be my maximum distance from the walls? It is simple. 1/2 of the allowable distance, 15, which is 7.5 feet. So this is the 7.5 feet. This is the maximum spacing between sprinkler and wall. Next, we need to check the minimum distance from wall. The minimum distance from wall is given here as 4 inches. See, this is the minimum. 4 inches is nothing but, I think it is 1 feet. No, not 1 feet.
10 centimeter.
Yeah.
3 feet, boss. 10
3 feet.
centimeter, 10 centimeter.
1 minute. 100 mm, okay, or 0.1 meter also. You can also call it as 0.1 meter,
Yes.
or 0.1 meter into 3.28 will give you 0.3 feet actually. Or simply you write 4 inches, minimum spacing is 4 inches or 100 mm. So this is the minimum value. Next, we are left out with minimum spacing between two sprinklers. So minimum spacing between two sprinklers, something is given here. See, minimum distance between sprinkler, unless the requirement are met, sprinkler shall be spaced not less than 6 feet on center. So here they have given the 6 feet they have given, or 1.8 meter. So we got all the values. Now tell me why these values are important to us. So the same thing I have written here also. I have just taken one example for standard pendant upright. Same thing I have written here, 225, 15, 7.5, 4 inches, okay, and 6 feet. Now, why these values are important to us means, suppose just imagine this is your space and you have placed sprinklers according to this positioning, okay, like according to this standard. Suppose I have placed sprinklers like this, and suppose there are 4 sprinklers I have placed. But when you go for the coordination, so in the coordination, what happens? Just in place of your sprinkler, sometime what happens? Some lights will come here, or sometimes any HVAC like duct will pass through this particular position, or any diffuser will come. Anything
Grill diffuser,
grill will come.
diffuser, or
What
smoke detector,
anything smoke
motion
detector,
detector.
anything will come. So that time what we can do, since we have the ranges given here, like we have the ranges given like from 0.3 feet up to 7.5 feet, you can go for walls, and 6 feet to 15 feet you can go for between two sprinklers. So you can place in between this, anywhere you can place. Suppose if you want to little bit move this sprinkler, you can place here also, because we are not violating the NFPA rules. And sometimes what you can do, you can place one extra sprinkler here also, like that also you can do. The most important question comes here. This one will be the most important question. See, normally sprinklers are placed like this. One sprinkler is placed here, one sprinkler is placed here, one sprinkler is always, you have to place in this pattern only, zigzag pattern. Because why in zigzag pattern? Normally what happens, if you place in zigzag pattern, so it will be very easy, like in calculation part also very easy. Now just understand one thing. Here I am not bothered about these two sprinklers. I don't bother about these two sprinklers. I am bothered about these two sprinklers, the spacing between these two sprinklers. I am not bothered about this sprinkler and this sprinkler. Okay. We are not calculating the distance between two sprinklers, but we have to calculate those sprinklers which are coming in one line. Try to understand this point, because whenever we are talking about this point, the minimum spacing, the maximum spacing, it is only talking about the sprinklers which are like parallelly, which are parallel to one another. Sometimes what happens, this sprinkler and this, suppose you have installed one sprinkler here. If you check this distance, the distance between these two sprinklers, the distance will be very huge. But you can check that these two sprinklers are not clashing. Why? Means because this sprinkler is in the east wing, this sprinkler is in the west wing. I'm just giving you an example. So we have to always check the sprinklers which are coming in one line. There only we have to follow this standard. Okay, this particular 5 points are for the sprinklers which are exactly in one position, or parallel, like which are coming in one, what you can say, in one positions only. You should not compare this sprinkler with the opposite side sprinkler, because sometime what happens, we will do this mistake and we fail to design the perfect sprinkler system. Okay, so this is the most important point here. So after this, you see,
Mr. Atif, Atif. Now, for the branch sprinklers, you put only one sprinkler. What about in the branch if you have, for example, 1-inch pipe? I think it can accommodate 2 sprinklers.
I'm
What will
giving
be
you
the
one
distance from
example.
the main and the first and the second?
See, you can connect like this also. If you want to connect some sprinklers like this, you can connect like this also. Suppose you have like place 2 sprinklers in this pattern, but I can avoid this positioning. Suppose if I want to place 2 sprinklers here, so what I can do, I can go in a very better way also. Like I can go like this also. One sprinkler I am placing here, one sprinkler I am placing here. It looks little bit nice as compared to if I am placing like this. Okay, just you can only tell which one is looking nice, this one or this one. Because here what, okay, both
Very good.
only, both look
is-
same only, but this kind of patterns are always very, because whenever you are doing the drafting part in a sprinkler system, you have to be very much cautious because you are trying to connect 5,000, 10,000 sprinklers in one network of pipe. So sometimes you have to avoid, or sometimes you have to avoid what you can say, some sprinklers, or sometimes you have to avoid the complex design. Like I'm connecting one sprinkler here, then connecting one sprinkler here, then connecting one sprinkler here. Don't go like this because it will obviously it will create some problem when we are going for the hydraulic calculation. So instead of this, we can do like this also. Suppose I want to connect 5 sprinklers here. Suppose in this region, I want to connect 5 sprinklers. What I can do, just I can take one branch pipe here, one sprinkler here, one sprinkler here, one sprinkler here, one sprinkler here, and one sprinkler here. Now this looks little bit nice because all the like sprinklers are placed, okay, whatever, however I want. And in the same way, I can also follow this pattern here also. Like suppose I want to connect 4 sprinklers in this region. So what I will do, just I will take one. Okay, I will just check what is the like distance between these two, because it should not go very much near to that. One sprinkler here, one sprinkler here, one sprinkler here, one sprinkler here. Now this design also looks very beautiful. Or you can also connect, see here I have connected 9 sprinklers. Or you can also connect like this, all the sprinklers in one line, 1, 2, 3, 4. But I don't think this design will be very suitable because it will not cover all the space. As a firefighting design engineer, our aim is to cover maximum space as possible, because when fire occurs, at least our all the spaces should be preoccupied. Okay, so there are a lot of designs, lot of patterns which you have to practice. Okay, this is why I am telling you that the sprinkler chapter is very important actually, because there are a lot of patterns which you have to work on, and you can make it. And all these things, how you can justify means with the help of our hydraulic calculation. With the help of allied calculation, we can justify our design. Okay, let's move quickly. Now these things are done. Next, here they have given one section, deflector position, like how to place the deflectors, unobstructed construction. Just leave this thing. Just try to focus these drawings. Some drawings are given here, how you have to place the deflectors. But I will say that these drawings are given, but still we have to check the real site conditions, because real site conditions are entirely different as compared with this whatever the Nfpa has given. Okay, they have given how to place sprinklers when you have this kind of arrangements, and where the sprinklers.
This is warehouses.
Sprinklers, yes, how the sprinkler
Warehouses.
connect. If you have a step false ceiling, like this is the step false ceiling, you can say, and this is the warehouse type. But you can just go through that, but still you have to check the real site conditions, then only you can select. So many things are given here, deflector orientation. So this kind of thing you will find in every sprinklers. See here, how to place the sprinkler if you are placing in the center, exactly in the center if you want to place. So how you have to place, that thing is given here. If you are placing the sprinkler in a rampant, like ramp kind of thing, suppose if you want to place sprinkler below the ramp, how to place, this is given. And here they have given positioning of sprinkler to avoid obstruction to discharge. So something is given, but these things are not required actually, because anyhow we will be following the NFPA standards. And here you see, if any obstruction is coming, the ceiling is there, how you have to place the sprinkler, what is A, what is B, some things are written here. If the obstruction is here, if the obstruction is in the center, like that they have given here. Okay. And here they have given some obstruction against wall. This is the also obstruction against the ceiling. So these things you can just go through that, because these things are required in the installation time. Whenever you are going for the installation, you need to check these things, how the obstructions and all are coming. Here also you see the obstructions are given, some elevation and all those things are given. So you can just leave this. These portions are not required actually. Sprinkler shall not be required in ceiling pocket where all.
This for the installation on the site.
Yes, yes. Whenever in the site you are going, you have to check the site conditions. Based on site conditions only we can install. Unprotected ceiling does not exceed. See here, this is also one of the important points. Ceiling pockets in every like you will find, sprinkler shall not be required in ceiling pockets where all the following are met. The total volume of the unprotected ceiling pocket does not exceed 1000 square feet. The depth of the unprotected ceiling pocket does not exceed 36 inches. The entire floor under the unprotected is protected by sprinkler. Some points are given. So whenever you are going to the site, just you need to check some things. But as a design engineer, if you are designing for a complete building, if your whole room is protected, then you don't need to bother about these things. Just you need to visit the site and check whether your positioning of sprinklers are right or not. And you have to get the coordinated drawings. With the help of that coordinated drawings, you can just shift your sprinklers little left and right. Otherwise, everything is fine. So these certain things are given here. Next section will talk about the sidewall standard spray sprinkler. Same pattern will follow here also. All the 5 points are given here. See, protection area and maximum spacing for light hazard and ordinary hazard. Here they have not given the extra hazard because sidewall sprinklers are not used for the hazards. Only it is used for the, and here how they have given maximum distance along the wall, maximum room width, maximum protection area. So I think they have given something like this. Okay. Sidewall sprinklers are installed in this pattern. Suppose this is one sprinkler, this is one sprinkler. So this particular can be called as along the wall. So here they have given maximum distance along the wall. So this is the maximum distance. Here they have given 14 feet combustible, non-combustible. So we have to go with the non-combustible only. For light hazard it is given 14 feet and for ordinary hazard it is given 10 feet. And the maximum protection area is given 196 square feet, 100 square feet. 2 points are given here. In the same way, the minimum distance, maximum distance is also given. Minimum distance will be always 4 inches. The maximum distance from wall shall not exceed 1/2 of the allowable distance. So in this case, 1/2 of the 14 feet, which is 7 feet. In this case, 1/2 of the 10 feet, which is 5 feet. And minimum distance between sprinkler is shall not less than 6 feet. So all the 5 points are given here in sidewall spray sprinkler also. This is the standard one. Okay. And rest every points will be same, like deflector position, how the obstructions are coming. So rest everything will give you almost same. And after that you go point number 8.8. See here, extended coverage upright and pendant spray sprinkler. Can you tell me what is the difference between standard upright pendant and extended coverage upright pendant sprinkler? Any idea? Any idea what is the difference between these two? Because first section we have seen 8.6 standard spray sprinkler. Here they are talking about the extended coverage. Simply just try to understand that whenever we are talking about the standard, in the standard, the protection area was 225 square feet. And whenever we are talking about the extended, in the extended, the protection area will be 400 square feet. This is the only difference between standard and extended. So here you will see extended coverage, upright and pendant spray sprinkler. See here, the maximum protection area, obstructed. Again, you have to go with the obstructed non-combustible type. 400 square feet is the maximum area. Light hazard, ordinary hazard, extra hazard, high piled storage. So here they have given the spacing also, here they have given little bit extra, 20 feet. Okay. In the standard one, it was given 15 feet. Here it was given 20 feet. Even ordinary hazard also 400 square feet, 20 feet. Minimum distance, again, they have given 4 inches. And the minimum distance from wall, again, 1/2 of the allowable distance, which is 10 feet here. And the minimum distance between two sprinkler is 8 feet. Sorry, minimum distance between two sprinkler is 8 feet. The same thing I have written here also. Extended coverage, 400 square feet, 20 feet, 8 feet, 10 feet, 4 inches. In the same way, there are different sprinklers like CMSA and ESFR sprinkler, which will come little bit down here. See, again, the same thing, obstructions and all, it will show. Just leave this. And if you go 8.9 section, we'll talk about the extended coverage sidewall spray sprinkler. Again, for sidewall spray sprinkler, they have given the table, protection area and the maximum spacing, 400 square feet and 28 feet. Now, the difference between sidewall spray extended and normal pendant spray extended pendant is that the spacing here is more, 28 feet. And the spacing in the extended pendant and upright is 20 feet. This is the difference. Rest, minimum distance between sprinkler, again the same thing. Minimum distance from wall, again 1/2 of the allowable distance. Minimum distance from wall, 4 inches. Minimum distance between sprinkler shall not. Okay, something they have not written here. The sprinkler shall not be located within the maximum protection area of least, even with the deflector of pendant. They have not given anything about the minimum distance between sprinklers. Okay, two sprinkler, only one is given. Sprinkler shall not.
Extended sprinkler.
This is the extended sidewall sprinkler, extended coverage.
Extended coverage of the sidewall sprinkler. This is
extended coverage. Yes, extended coverage is when you want to use less sprinkler, more coverage area. Go with the extended coverage sprinkler. If you want to use more sprinklers, go with the standard sprinklers. Next you will see some residential sprinklers are given. So residential sprinklers are also one type of sprinkler. So they have not given anything much about this residential sprinklers. You can skip this because this is rarely, I think, it is used. After a residential sprinkler, they will talk something about. Okay, this everything is talking about the ceiling pockets. Okay, no, not ceiling pockets. CMSA sprinklers. Now, CMSA sprinkler means it is control module specific action. So, these CMSA sprinklers are used in mostly in the extra hazard areas, industrial areas, because there are some specific type of sprinklers which can quickly act. Okay, they will be acting very quickly. Protection area sprinkler, again, they have given the tables here also. See, this is that protection area and maximum spacing of CMSA sprinkler. Now, I will tell you one thing. When we go for this storage type of building, so in this storage type of building, you will find more details about the CMSA and ESFR sprinkler, because in storage type of building, they are using these two types of sprinkler only, CMSA and ESFR sprinkler. Okay, ESFR sprinkler is nothing but early suppression, fire response, something like that. So this is also very sprinkler used for the industrial purpose only. So here so many things. Here I have already written what is the spacing and all. You can cross check here. Okay, the same things are given here. You can just cross check this CMSA, and after that 8.12 will be the this one. What you can say, ESFR sprinkler. See, this is the ESFR sprinkler, early suppression, fast response sprinkler. So if you skip this chapter, almost we have covered this chapter, because in this chapter only we have to focus on these 5 points. Whatever the 5 points are written here: protection area, maximum spacing, minimum spacing, distance between wall and sprinkler, maximum and minimum, and some unobstructions are given, some images are given. Just try to follow those things, and this is more than enough for you. Now next chapter is a little bit important. So there are so many things are given here, like different building. These are the clauses given. We don't need to bother about these clauses because there are so many clauses are given. So whenever you are designing any specific building, then only you have to come and check that particular clause. Okay. Otherwise, it is just talking about some clauses, how it should be there, and all those things are given. And after that, some fittings are also given here. They have given something about the piping installation also. Like see this chapter 8.16, they're talking about the piping installation, how the walls and all will be there, supervision, so many things are given here. So here I have highlighted some point. Okay, check walls. Some walls are given here, control walls, check walls. When there is more than one source of water, a check valve shall be installed in each connection. So this point I have highlighted just to remind you that you have to study these documents also. When there is a more than one source of water, a check valve shall be installed in each connection. A listed backflow prevention device shall be considered a check valve, and an additional check valve shall not be required. Some things are given here. Okay, control valve with check valve. And here I have highlighted some pressure reducing valves. So here it is telling that in portion of system where all components are not listed for pressure greater than 175 psi and something is given, a listed pressure reducing valve shall be installed and set for an outlet pressure not exceeding 165 psi at the maximum inlet pressure. Now you need to start understanding these pressure ranges.
Where you are using pressure reducing valve? This is in the plumbing. Why it is in the firefighting?
Now the same question I was coming to that. If any client is asking you why to use pressure reducing valve, if anyone is asking you this question, so this is the best answer. This point is telling that the maximum pressure. Okay, yesterday I think I have shown you.
Yeah, 175. I remember 175 psi.
175 psi is the maximum.
12 bar. Yes, I remember.
So here what it is telling clearly, if suppose now obviously 175 psi pressure will come for the high rise building only. For low rise building, it is impossible to attain this particular pressure. So if you are not confident enough that the pressure will increase, so it's better to use PRV valve, pressure reducing valve. And here they have given a listed pressure reducer shall be installed and set for an outlet pressure not exceeding 165. You have to use a pressure reducing valve of 165.
Boss, at the discharge for the fire, after the firefighting pump discharge line, we can use water relief reducing pressure line. It will go back to the water tank firefighting. It
Yes,
will reduce
you can use that. But this is here it is telling that whenever you are, if anyone is asking you why to use pressure reducing valve, this is the answer.
Yeah, okay.
Sometimes you can go with the smaller pressure reducing valve also. Suppose if you want to go with, actually there are two modes actually. One is the system mode, one is the demand mode. When we go to the Allied software, so there will be two modes. So in the system mode, I think we will do system mode. Like in one, suppose if you want to set particular pressure only, I want my system should not go more than 50 psi. So what I can do, simply I can install one pressure reducing valve of 50 psi. My system will never go more than 50 psi. Okay, this is one thing. So I will show you in Allied software. So one is system mode, one is demand mode. We can calculate in any either we can calculate in demand mode or we can calculate in system mode. So that I will show you when we go for the Allied calculations. Now after that, pressure gauge shall be installed on the inlet and outlet side of each pressure reducing valve. Okay, some points are given and so many things are given. You can just go through that, because when we go for the schematic drawing, I will explain you about the valves also, like what valves are installed there and how valves are installed here. They have given about the drainage also, like you have to install one drain line. Okay, whenever you are installing sprinkler system, this is some point is given. And here the size is given. Remember, I have like somewhere I have written this drain. I think here I have, in the last page, I have written here, this particular I have taken from here only. The riser or main, the size of the drain connection. So this particular exactly I've copied from here. So these are the things, and rest. There are so many things are given, which you have to go through that. Water flow alarms, sprinkler alarms, fire department connection. They have given something, how the fire department connections are connected. Here they have given the schematic arrangement of fire department connection. You can go through that also. And so many things are given. Main drain test line. We have to go with the drain test line also. So that also I will show you in the schematic drawing. And apart from that, I have not highlighted some points, but these points are little bit important. You can go through these points. Hose connection for fire department use. Here I have just highlighted some point here. In building of light or ordinary, okay, 2.5 hose valve for a fire department shall be permitted to be attached to the wet pipe sprinkler system. Here they have given clearly the size of the hose valve, 2.5 inches. So actually there are two sizes available, 65 mm or 40 mm. So 65 mm or 2.5 inches is used for the like one size, and one is the 1/4 inches. So that we will see in the Nfpa 14. But here I have highlighted, okay. And here you can just go through these points also. Some points are given here. Next, chapter number 9 is for the hanging, bracing and restraining of system piping. Like suppose if you have installed the piping and all, what is the rod and all, those things they have given, hangers, rods. So here all the structural details are given, which is not required for us. See here, they have given minimum bolt size for steel, minimum bolt size for concrete. These are the structural details. We don't require these things. But additionally, if you want to go through this, you can go through that whenever you have time. The maximum distance between hangers, maximum distance between hanger in inches and feet. Those things are given. This is the pipe sizes are given. And what is
is this the hanger support for the pipe installation?
Yes, hanger support for the pipe installation. So many things are given. Locations of hangers on main lines, those things are also given here. This 9th chapter is entirely for it is helpful for those who are into the installation practices, like who are doing the installation practices. For them it will be very helpful. But most of the things are structural based only, so we don't require this. Loads and all, maximum loads, those things are given here, so we don't need to bother about maximum horizontal loads. We can skip this chapter. And here also they have given some technical structural details only, so we'll get confused if we start studying those things. Now next, chapter number 10 will come, underground piping. Now again, here also they will just talk about some pipings and all, which type of pipe we have to use and all. So this is also not required. You can skip this. All these things are not required for us, because here mostly they have done the structural calculations and all. Chapter number 11, design approach. So design approach, here I have highlighted one important point. See, here you will understand the difference between the pipe schedule method and the hydraulic calculation method. So how to identify what pipe schedule method and horizontal method is that? Because of this table. Here they have given the table. In the pipe schedule method, clearly they have given the minimum residual pressure requirement, okay, which is 15 psi or 20 psi for ordinary hazard, 15 psi for light hazard. And here they have given the stream allowance, hose stream allowance, how much water we can use for 500 GPM for 30 minutes. Okay, now just remember this table, because whenever we are going for the allied calculation, I will explain you that time clearly what is the meaning of this table. Minimum pressure is given 15 psi, and here they will give you the minimum pressure. Okay, here they have not given the minimum pressure, but hydraulic calculation minimum pressure is 7 psi. Okay, this is the hydraulic calculation, and the pipe schedule calculation minimum pressure is 15 psi. This is the only difference between hydraulic calculation and pipe schedule. If you give 15 psi, that system is called as pipe schedule. If you give 7 psi, the system is called as hydraulic schedule. Obviously,
Here, how we know that we have to use pipe schedule method or hydraulic method?
see, if you are in Allied software, it will ask you the minimum operating pressure. So that time you have to write the value. If you have written 7 psi, so obviously it will be hydraulic calculated. And if you are writing 7 psi, the pressure, the main pressure will be less only. And if you are writing 15 psi, the main pressure, or what you can say, the main pump pressure will be higher. We have the limitation 175 psi. So always try to remember this point, that we cannot go more than 175 psi. If I am giving 15 psi, there may be chances that if I am doing for high-rise building, very high-rise building, there may be chances that my pressure may go beyond 175 psi. So that's why Allied software will recommend to go with 7 psi only. Actually, it is 6.9 psi given in books, but software will take 7 psi only. So that point, when we will see the Allied software, you will understand that we have to take this 7 psi only.
Okay, I cannot understand that if we are designing some building, say 5-story building or 10-story building, so where we will use hydraulic method or where we will use pipe schedule method. Yani, if it is ordinary hazard, so how we decide that we have to use pipe schedule or yani, or
See,
depend on client or how yani?
no, we have to we have to always go with the hydraulic calculation method only, because in Nfpa 13 also they have given the steps of hydraulic calculation method. But in pipe schedule method, they have not given anything. But I don't know whoever is following this pipe schedule method, but I can say definitely that those who want higher pressure, suppose sometime what happens, you are getting the higher pressure, you cannot reduce the pressures. So that time they can go with the pipe schedule method, because in pipe schedule method, the pressure ranges are very high, because the minimum pressure given here is 15 psi. So just imagine what will be maximum system pressure. And here the minimum pressure is given 7 psi. So there may be chances that we can go. But normally I have not come across any client or any consultant that they are recommending pipe schedule method, because everyone will follow hydraulic calculation, because hydraulic calculation is very simple to do calculation as
And
compared.
also for the sprinkler itself, they have their requirement. Na? Yani at what pressure they will work properly, 7 bar or 6 bar or 15 bar.
Yes, yes. The minimum pressure for sprinkler is also given. So this is only the minimum pressure for sprinkler, 7 psi, or it will be 0.5 bar. So every sprinkler should operate at this pressure. This is the minimum pressure it should operate. If any sprinkler is not operating at this pressure, then the manufacturer has to change that sprinkler. Because when we are doing the calculations, so we are expecting that all sprinklers should should have this pressure. That is why they have given the term residual pressure. This residual pressure is calculated for the farthest sprinkler. Suppose if you have the 10th floor building, in the 10th floor, the farthest sprinkler, they will check what is the residual pressure. If it is coming 7 psi, then our design is fine. If it is not coming 7 psi, then our design is failed. So we have to again redesign it. So just imagine if my farthest sprinkler is 7 psi, then all the sprinklers should we will expect all the sprinkler to work on 7 psi only. So this is how the firefighting system works actually. But
That's why we use the hydraulic, because
yeah. In Allied software, everything is very simple, because Allied software gave us step by, like in each sprinkler, we will get to know what is the pressure we are getting. The minimum pressure we will get more than 10 psi only. When we do Allied calculation, minimum pressure we will not get 7 psi but 10 psi or 12 psi, because we have given the minimum pressure value as 7 psi. If we have not given minimum pressure, residual pressure, then We can get any value, 3 psi, 4 psi. The design will be actually.
That's why you put the hydraulic, because the minimum is the
Yes.
sprinkler.
Minimum.
The indoor hydrant, hose reel 4.5 bar. The outdoor hydrant 6.7 bar, right?
Yes, that is the hydrant system. 65 psi or I think 40 or 65 psi. Something is
Which
given.
one? Which one?
Hydrant, for hydrant system. It is given
Hydrant.
in NFPA 14. It is given in NFPA 14. They have given the ranges. We will see that tomorrow. And here they have given the density area curve also. This is also important for our hydraulic calculation. So here they have given density and area of sprinkler operation. In square feet, this is the density. So for light hazard, the density is 0.1 GPM per square feet. Ordinary 1, 0.15, ordinary 2, 0.2, extra hazard group 1, 0.3, extra hazard group 2, 0.4 GPM per square feet. If you want to check in mm per minute, this is the values. Like mm per minute is only considered for extra hazard, 8.1, 12.2. Also, you can take for this one, but here they have not given any value for light hazard. For ordinary and extra hazard, you can go, but mostly we will go with this value only. After that, one more important table is given here. Home stream allowances and water supply duration requirement for hydraulically calculated. Now, this is the most important table. Just remember this. We will discuss when we go for the hydraulic calculation. Like this is the maximum demand what we can always design for any hydraulically calculated building. Just remember this. We will say this later when we go for the calculation. And after that, I don't think much things are given here. Just quickly, I will see. And tomorrow we will see. See, this chapter is for the storage. Now, as I told you that I want to skip this chapter. Why I want to skip this chapter, I will show you. It is very complicated actually. There are so many tables given here. It will start. Some tables will start from here. And there are so many different buildings are given. Pallets, wood pallet, idle pallets. And so many tables are given here. So if we start like understanding these tables, we will get confused. There are so many tables given here. So that's why I told you this topic we will take a little bit separately. Storage chapter. Yeah.
We will take it later.
Yeah. This topic we will take it later because there are so many 6 to 7 chapters.
Both skip it, please. Otherwise,
Yes,
you'll be confused. Skip it, please.
There are so many. See, I will show you till where it is. I think up to 20 it is there. Chapter number 20. So many things are given here. So normally these chapters are only considered when you are doing that particular project. Otherwise, no one will like go to that because so many tables, so many figures, images are given here. So we don't require this for now. But one day we will definitely sit here for this and we will complete this topic. See, even this chapter number 21 is also comes under storage only.
There was, as you say, the PRV valve. If we are designing a 13 or 15 story building, in the standpipe, the pressure may be 200 psi. So
we cannot design for 200 psi because some pressure is
okay, 175 psi.
Yeah.
175 psi. Okay. So in 5th floor or 6th floor, when we take a branch, as per the sprinkler requirement, we will set a PRV for 15 psi or 10 psi maximum. But do we need another PRV valve for hose? Because it need only 4 to 6 bar.
No, I don't think we require because if you are setting the PRV in the main line only, I think it is required for our we don't require for different floors because here only we are trying to set the pressure. If we are restricting this pressure and this pressure when we have to install this PRV, if we don't have the confidence that our building pressure will go more than 175 psi. Otherwise, your allied calculation will give you the maximum pressure limitation. Like what is the maximum pressure your building can get. And if you can add 10-20% extra also, nothing will happen, because it can never go 175 psi. But when you are how this pressure will come means, suppose if you are adding too many sprinklers, just imagine if I'm adding too many sprinklers and I'm adding so many hose connection, so there may be chances that my pressure can go near to this 175 psi. If I'm not adding much sprinkler, much hoses, then definitely it will not go. But still, if you are designing for high-rise building or any building, it's better to go with the PRV. And suppose if I'm getting 65 psi here in the main line, so I can set the PRV to this range only. Or if you add 10-20% extra, and you can set any value here, 70 psi, 75 psi, because sometimes clients are very much concerned about this pressure. So it's better to go with. And here we can only keep one PRV, which is more than enough. Like if you see in plumbing we can go for different PRVs. Like in one floor, second floor, third floor, fourth floor. Here also we can go with PRV. But in firefighting, I don't think we require PRV, because anyhow we are using the zone control walls here in every floor. So I don't think we require the PRV in each and every floor. If we are installing one PRV, it is more than enough, especially for the high-rise buildings. Or you can divide into two sets also. Like maybe you can divide into two sets. If the pressure is very high, we can what you can say, we can downstream or upstream the pressure, like that also. I will show you the schematic, you will understand the schematic. It is given about the PRVs, so you can understand that. But as per NFPA, it is telling if the pressure is going more than 175, then only you have to use PRV. Otherwise, I don't think they have given to go with the PRV valves. Anyhow,
Mr. Atif,
the check valves. So, yeah.
Mr. Atif, we have installed for each indoor hose reel cabinet PRV plus lock shield valve. There is PRV for the indoor hose reel cabinet, for each cabinet. The hose reel, the 1 inch and the 30 meters hose reel wheel. There is PRV inside the cabinet,
Yeah.
plus lock shield valve.
If like again, if the pressures are very small, then I don't think we require, because it will be additional cost to the company only, or the one who are installing the system. If the pressure ranges are more, then it is recommended. We cannot skip this PRV. So that is the thing actually. If we are installing PRV at every places also, I don't think like I have seen any document in NFPA where they are keeping mandatory for what you can say, this PRVs. But still I will search if I get anything related to that. Okay. Now this chapter number 23, plans and calculation. I think from here, next important part will start. Now here they have given the hydraulic calculation procedure for, okay, like calculation procedure, but this is the NFPA format actually. Okay. This is the NFPA format, and they have given
This is documentation.
Documentation.
Yes, to close out. It will be used to close out and the history of the project and to close out the project.
Yes, but we are not going to follow this particular method, because we will be following the allied calculation method. The allied calculation documentation method is little bit different. Here the documentation, like how the calculation sheets and all, they have shown NFPA. So these things we are not going to follow. And after that, from this portion is little bit important again. Hydraulic calculation procedure is given. I think the time is very we will continue this tomorrow. So some things are given about the hydraulic calculation. So if you understand this hydraulic calculation procedure, so then we will directly tomorrow what we will do, we will check this portion, and NFPA 14 and 20 also we will see. NFPA 14 is a very small topic, and NFPA 20 is also there. For fire pump, this is also very small topic. So this thing tomorrow we will try to complete this. Okay. And then we will next day we will see some requirements about the NBC also. Then we will directly jump into the hydraulic calculation. So once we are through with the hydraulic calculation, it will be very easy for you to understand the entire firefighting system. Okay. So we will meet tomorrow and we will complete this NFP 13 and 14. So why I have taken this much of time? Because you will understand it clearly and it will be very much helpful. There are so many things actually which I might missed out. So it is your duty to go through each and every point. And obviously in one day you cannot become expert in any standard book. We require time. Even I have never get any chance to study each and every point from NFPA. But whatever, like I have highlighted some points, you can just like go through those points. And there are so many things given in NFPA also, which you will understand. Okay then. So we will stop here only today and we will meet tomorrow and we'll complete this NFP 13, 14 and 20. Okay. So I will stop this.